Good morning. In today's lab experiment, we will be determining various types of solids in wastewater. So basically, this experiment deals with analysis of different types of solids in wastewater. And this will be done using a method called gravimetric method. What do you mean by gravimetric method? Basically, you are calculating the difference in the weight by taking the weight of a crucible, by taking the weight of the solids. That is why it is called as gravimetric method. Usually, the wastewater or sewage, when we are analyzing it for solids, it contains 99.9% of water and around 0.1% of total solids. And these total solids, the organic matter is around 45% and inorganic matter is around 55%. So again, in the solids in the wastewater, again, they will be having organic solids and inorganic solids. Basically, the inorganic solids which will be there in the wastewater, they contain mineral, salt, sand, gravel, debris. Uh, Basically, they are not degradable in nature. So those are called as inorganic solids. Whereas the organic matter consists of carbohydrates like cellulose, cotton, fiber, starch, sugar, fats, oils, nitrogenous compound, sometimes proteins and other decomposable matter. So basically the solids which are there, they are divided into two types, organic as well as inorganic. Organic which gets degraded, inorganic which will not degrade. Now there is another part called suspended solids in treated or untreated effluent. It should not be more than 100 milligrams per liter as per Central Pollution Control Board (CPCB) norms. Remember, for water, drinking water, we follow BIS standards, BIS 105 500 2012, but whereas for wastewater we follow the norms given by Central Pollution Control Board. Okay, so standards for the disposal into the natural surface water bodies like rivers and lakes, this standard should not be more than 100 milligrams per liter for suspended solids. Now, how exactly these solids get divided? Okay, there are different types of solids. You can see that set level solids are there, who will have its particle size greater than 10 micrometer. Okay, set level solids will have bigger particle size. Suspended solids will have particle size which will range from 1 micrometer and less than 10 micrometer. They are also known as non-filterable solids. That means they will not get filtered, they will be remaining on the other side of the filter. Okay, so they will get sustained, retained on the filter paper. And then you see a colloidal solid. The colloidal solids will have still lesser particle size of 1 micrometer to 0.001 micrometer. And then there is something called dissolved solids. They will have still finer particle size of 0.001 micrometer. Now when you look into colloidal solids and dissolved solids, they both are filterable solids. That means if you allow them to pass through filter paper, they will come on the other side of the filter paper. That means they will not get retained on the filter paper. So colloidal solids, a colloidal solution, when we say milk is a colloidal solution, whereas if you are putting a sodium chloride in a water and dissolve it, you can see a clear solution of sodium chloride. That is what is dissolved solids. Okay, now when it comes to different types of solids, there are different types of solids which are present in wastewater or spent water or sewage. So there are 5 different categories which are mentioned here. First one is total solids. We call it as TS. Total suspended solids, those which are in suspension. Total dissolved solids, those which are in dissolved form. Total settlable solids, those which can settle. And fifth one is total volatile solids. Here you have organic as well as total fixed solids which are inorganic in nature. Now let's see one by one how to analyze them. Now, if you look into total solids, if you want to analyze total solids in the wastewater, what you are supposed to take? You take evaporating dish or Guj crucible. We call it as Guj crucible. This will withstand elevated temperatures. So you take that evaporating dish or Guj crucible, which should be oven dried. Why it should be oven dried? So that you will remove the moisture associated with that particular crucible. And note down the initial weight as W1 grams. So you note down that it as W1 grams. Okay, so this is empty weight of gooch crucible or empty weight of evaporating dish. You have to oven dry to remove the water if it is there or moisture which is associated with it, and then take it as a W1 gram, and you keep it on a weighing balance after cooling it down. Okay, so oven dry and cool it down to the room temperature and measure it as W1 gram. Okay, fill the crucible. Next step is fill the crucible with the wastewater sample of known quantity. You have to take known quantity. You have to measure the known quantity and then transfer this wastewater into the crucible and place it on a burner. Now you have to take that known quantity of the wastewater in a crucible and place that crucible on a burner. Then what you have to do, allow this water to evaporate completely. So you have to evaporate the wastewater from that particular thing. Then cool down the crucible in a desiccator. Desiccator is a place where they put silica gel. Basically it will not come in atmospheric moisture content. That is the reason why you have to keep it in a desiccator. Now once it is cooled in a desiccator at room temperature, take down that particular crucible and measure it as W2. You measure that weight of that crucible, it will be W2. Now naturally the W2 will be greater than W1 because you are having solids which are left out in the weight W2. So the formula for total solids is milligrams per liter is equal to W2 minus W1 into 10 raised to 6 divided by ml of sample taken. Okay, so that conversion is there. That is the reason it is 10 raised to 6. This is how that good crucible looks like. Okay, now that is how you find out total solids. Now how to find out total dissolved solids. So if you want to find out how much solids are dissolved in that particular wastewater, what you have to do, again same procedure, take an evaporating dish or gooch crucible in oven dried, note down the initial weight as W1 grams, fill the dish with the wastewater sample of known quantity, but there is something which is very important in this. How you have to fill it, there is a slight difference compared to earlier thing. So fill the crucible dish with wastewater sample of known quantity after filtering it through a filter paper. So we use Wattmann filter paper for filtering it and place it on a burner. So you are calculating dissolved solids. So you see, earlier case you are taking entire wastewater and evaporating, but in this case you are just finding out dissolved solids. How will you get a dissolved solid? By just putting a filter paper, and the filtrate part, you are taking a filtrate part of it, and then you are continuing the procedure same as earlier. Allow the wastewater to evaporate completely and cool it in a desiccator. So when you filter it off, what happens, some solids which are there on the other side, they will remain on the filter paper. Those are called as suspended solids. Actually they are called as suspended solids. So whichever are not getting filtered, they will get go through filter paper. We are on a filtrate side, that filtrate solid liquid will have dissolved solid. So that is the reason you have to filter it and take it on the other side, and take this filtrate and repeat this procedure. So after that, allow the water to evaporate completely and cool that desiccator in a desiccator. Note down the final weight as W2. So now when you look into this is how that filter paper looks like. Wattmann filter paper number 41. Okay. Now total dissolved solids again are calculated by W2 minus W1 multiplied by 10 raised to 6 divided by ml of sample taken. So already we have calculated total solids. Now we calculated total dissolved solids. Now if you want to calculate total suspended solids, you can do it by calculation as follows. Total suspended solids in milligrams per liter is equal to total solids minus total dissolved solids. So difference between total solids and total dissolved solids will give you total suspended solids. So if you look into the equation, always remember that total solids will have highest value, because total solid is equal to addition of total suspended solid plus total dissolved solids. So now in this case we have calculated total solids and we have calculated total dissolved solids. So you subtract total dissolved solids from total solids, you are going to get total suspended solids in milligrams per liter. Now, how will you calculate next part? There is something called settleable solid. The solids which are likely to settle on its own weight, those are called as settleable solids. So for this, you take 1 liter of representative sample, whatever it is, wastewater sample or water sample, and you have to thoroughly mix it and put it into something called Imhoff cone. It is called as Imhoff cone, and this Imhoff cone will be used to calculate settleable solids. Now, once you pour that 1 liter of water into Imhoff cone, allow the sample to settle without disturbing the Imhoff cone for actually it should be 1 hour. It is given as half hour here. It should be 1 hour. After 60 minutes, note down the result by taking the graduations from the bottom of the Imhoff cone. So that EMOF cone will have graduations which you can measure. Settleable solids are given in ml per liter. There is a slight difference, okay, in the units. There it is milligrams per liter in earlier cases, but here we are calculating in terms of ml per liter. So settleable solids are given in ml per liter. How, what you're supposed to do? You're supposed to take 1 liter of representative sample after completely mixing it, transfer that 1 liter into EMOF cone and allow it to settle it for 1 hour. After 1 hour, the solids will settle at the bottom of the EMOF cone. There will be graduations which are given on the EMOF cone. Measure those graduation and calculate how many ml of solids are settled in per liter of the sample. Per liter of the sample. Those are called as settleable solids. Basically, these settleable solids help us in designing some of those water treatment and wastewater treatment units. This is how that EMOF cone looks like. This will be made up of glass or transparent material, and the EMOF cone looks like this. Okay, so this will be given in a demo in lab. Then there is something called total volatile, organic, and fixed solids. Those are inorganic solids. So total volatile solids are called as organic solids, and fixed solids are called as inorganic solids. So what you're supposed to do when you're finding out this? Now, this is for your additional information. Okay, so you might not do this in lab. Okay, so take weight of empty goods crucible, oven dried, again same W1, pour known quantity of water, wastewater, after thoroughly mixing it into crucible and place it on a burner. Heat it till the wastewater gets evaporated, leaving behind the total solids in the crucible. So till this point, you know how we have found it for total solids. Same procedure you are repeating from this point. Okay, from this point to this point, everything remains same. Okay, so here you are calculating the total solids in a crucible. Now you have to cool this crucible by keeping it in a desiccator and note down the weight as W2. So you know that this is the calculation which is done for total solids. So this procedure remains same till this point exactly. It remains same for the total solids. So once you get total solids, same crucible, what is there, that crucible you have to keep it in muffle furnace. That crucible you have to keep it in muffle furnace. Now you see, you ignite the residue, that is the total solids which are found in that W2 weight of that particular crucible. That same crucible you have to keep it in that particular furnace, and you have in a muffle furnace for 30 minutes at a temperature of 600 degrees centigrade. At a temperature of 600 degrees centigrade. Now, after burning it at 600 degrees centigrade, total solids, in that total solids, you have to heat it for 30 minutes at 600 degrees centigrade. What happens? You are going to have some of those solids which are present in the total solids will get evaporated. They will get evaporated. So naturally, you are going to get W3 weight, which will be lesser than that of W2. W2 is total solids. So total solids minus W3. W3 is after evaporating those total solids at elevated temperature of 600 degrees centigrade. So W2 minus W3 divided by ml of sample, it is going to give you total volatile solids. Most of these organic solids at 600 degrees will evaporate and they will get converted into gaseous form, and that is why these volatile solids, total volatile solids, are called as organic solids. Okay. Now, how you are going to calculate total fixed solids? Now, already you know total solids, and this total fixed solids will remain with the system. The reason their boiling point is very high and the inorganic salts will not get easily evaporated. So those are called as total fixed solids, and they are called as inorganic solids. The nature of the inorganic solids is they will not get converted easily into gaseous form. So how you are going to calculate this? Total solids minus, already you know total volatile solids. So total solids minus total volatile solids will give you total fixed solids. So in this case also, always remember total solids will be having highest value. So from this, if you subtract total volatile solids, you are going to get total fixed solids. So this is the explanation for the solids, and this experiment you will be performing in lab, and lab videos, demo videos will be shared with you. Thank you.